So now we are going to talk about the dependence of electric field strength on the distance and its relation to the number of field lines. So first of all, you can check that we have taken a charge Q and placed it at a point O, and basically we can understand that the electric field lines from the charge would be coming out in all directions, but we have taken a specified lines just to make us understand what is happening in this situation. So first of all, we would like to check that the electric field lines coming out from this test charge is towards outwards, and that's the reason it's coming towards out. And we have taken two positions, that's one P1 and P2, where we talked about the area, and we can understand that this is not a two-dimensional figure, it's a three-dimensional diagram we have to imagine, otherwise we won't be understanding the situation. And after that, we could see that we have taken two small region of strong fields where we can represent with R and S, so which was talking about a very small area element where we have already checked with ds, we represented with ds. So here what we can see that the solid angle which comes out for a three-dimensional figure is represented with delta omega, and the figures that we will be talking now, which is talk about that as we move forward from the charge, the strength of the field lines decreases. So let's take some example and check out. So here we have taken a positive test charge. So yes, we have taken a positive test charge, and we can see that directions of the electric field lines are towards the outward, and we can see that as the distance increased, the portion started shading. Now if I try to move the charge, then you could see that the distance from the test charge, that's the positive charge, till some distance it showed me the strength, but when it started moving away from it, the field started showing it started becoming darker, it started fading. And that's how we understood that when we will move towards away from the charge, the strength decreases. Now what happened, let me take some other charge like a positive and a negative, and let me then see that what happens when the electric field lines between these three charges will show up to me. So this is how the electric field lines shows. Now what happened, I took the example with a picture which shows that as I'm moving away from the charge, and let me take a small area element equal of area, I could see the closeness, the density of passing the field lines is quite different from P and Q. You could see that in P around at least 2 to 3 field lines were passing, but in Q only one was passing. That proved that density of lines of force is proportional to the electric field strength.